Hello, everyone. Welcome to Data Platform Geeks webinar. We are super excited to bring 8 webinars to you this year. In fact, this is the beginning of our community activities, and we kind of each year start off with webinars along the same time when we announce Data Platform Summit. So there's a lot of good news that I would like to share with you. My name is Amit Bansal, and I am so glad. A very warm welcome to Data Platform Geeks. Let's begin. Very quick introduction about Data Platform Geeks, SQL Server Geeks, and who we are. So this should not really take more than 2 minutes of your time. So we started off way back in 2004 in a town called Calcutta, rather city, I should say, in a city called Calcutta in India. And if you can look at this very old picture, we precisely had just 7 people. So this was one of those user group communities, user groups that we organized, like a few people getting together and sharing knowledge with each other. So this was a kind of that user group meeting. And from that point onwards till today, if you look at this chart, and there's so much I can talk about that, but because of time brevity, I'll keep it very short. We kept growing organically. We organized so many user group meetings and community initiatives, webinars, in-person events, podcasts, virtual symposiums and webinars all over India, and then we moved global. And we had SQL Server geeks doing a lot of stuff around SQL Server. We had data platform geeks doing a lot of stuff around Azure data and analytics and AI in general. And one of our flagship offerings for the community was SQL Server Geeks Annual Summit, which we started off in 2015. If you look at the chart there, SQL Server Geeks Annual Summit transformed to Data Platform Summit, what we have today. So from 2015 to 2022, this is the 8th year of Data Platform Summit, and approximately 20 years of our community work. So big thanks to all of you. You have been supporting us, you have been liking what we have been doing, so kudos to all of you. This is one picture, and believe it or not, this is in my home. I framed this, and I keep it with me. This was Data Platform Summit 2019 in Bangalore. More than 1,000 people had joined us from 20 plus countries in this mega event. And friends, this was not the first edition of DPS. Of course, we started in 2015, but this was special because this was the year when we moved our event to completely next level. And look at the contrast. So when I see this picture from 2004 with just 7 people from Calcutta and in this user group meeting, compared to what we did in Bangalore with Data Platform Summit, 1,000 people from 20 different countries, it's a very happy moment for me, for our team members, and of course for the global data community. Look at these numbers for you, probably makes sense, where we started with 7 people and today we have more than 150,000 people from 108 countries with 14,000 organizations being members either of SQL Server Geeks or Data Platform Geeks. So great work, and it has been completely organic. This is the power of our community work. Continuing the journey, this year we have announced Data Platform Summit 2022. This is the 8th edition of this flagship signature event focusing on Azure data, analytics, and AI. This year, friends, the theme is athletics, because this is the time where athleticism is so critical. You as a data custodian today, you're being asked to do so many things around data. You're just not a SQL Server DBA or developer, but you're doing everything around data, both on-prem and cloud. And you're constantly running, constantly striving hard to learn, upgrade yourself, and keep your skills up to date. And we're playing a small part in organizing these community events to keep you up to date and keep you on toes. Some links are there in the chat window, and the biggest news is DPS is free. It's a digital event. It is coming right on your desktop, in your home, in your office. You can join at your convenience. DPS is free, so go ahead and join. That's the first thing you should do. Not now, but probably after the webinar is over. Join for free. Along with DPS, we have also announced the pre-cons. The first group of pre-cons have been announced. So let me tell you what are pre-cons. These are virtual classes. These are live virtual classes. Many of you already know about this. So this is going to be hosted just before the regular conference. So 8 hours virtual class will be divided into 2 consecutive days, 4 hours each day. This is something that DPS attendees, delegates, and alumni really look forward to, because we get you the topmost experts from the global community, from Microsoft, and these are very, very reasonably priced. Yes, I did mention about price. So while DPS, the regular event, is free for you to join, precons do have a slight cost associated with it, because of course it takes a lot of efforts for a speaker to put up 8 hour content and deliver it virtually. So from your convenience of home or office, you can join these classes. These are the 8 precons that we have announced as part of the first set of announcements. So you could see Dave Reiter doing something with Azure Synapse Analytics and Power BI. Then we have Jason with extended events. We have Query Store Deep Dive by Milos. We have Spark for Data Engineers by Tomaz. We have Marcus doing data and Power BI modeling. We have Nicola doing Power BI performance tuning in a day. And we have Dejan Sarka doing advanced analytics with T-SQL, followed by Dennis Torres on ETL for the cloud. And today's focus, out of those 8 precons, I want to have a special mention for Dejan today, advanced analytics with T-SQL. Let me tell you, friends, you are doing a lot of stuff around Python and probably machine learning and a lot of advanced tools, and you want to do a lot of analytics. Dejan is a world-renowned expert, Microsoft MVP, and a subject matter expert, does so much of great stuff with Transact SQL. SQL, yes, I'm talking about T-SQL, and it will be an eye opener for you to really unleash the power of Transact SQL and what you can achieve with Transact SQL. Dejan will show that to you. If you are keen in his on his precon or any other precon and multiples of them, you can use the discount code 60 steal it. Just look at the top there, 60 steal it, which will give you 60% off on whatever the precon price is any given day. We have a few limited seats, coupons of this discount code. So if you're really keen, just go ahead and make the booking. Now, true value. With 60%, of course, you are going to get this even lesser than $174. But what I mean by true value is no conference on this planet offers you pre-cons, these live classes, at such low prices. And additionally, you get the recordings also. We are very thankful to our speakers who allow us to record the pre-con so that we can share the class recordings with you. And you can watch them over the next 12 months anytime, as many times as you want, anywhere. And that's why I use this phrase, true value. So take advantage of this, leverage this great opportunity. Don't just go register for one precon, but you could actually go and register for multiple precons. Let's talk about some key highlights of DPS 2022 this year. Multiple editions. Friends, this is the first time DPS is bringing you 5 editions. ANZ edition, Australia and New Zealand, APAC edition, Asia Pacific. Then we have the IST edition for India. We have EMEA edition, Europe, Middle East, and Africa for the EMEA folks. And then we have the Americas edition for North America and South America. So this covers the entire globe. Wherever you are from, you can attend DPS, and you would register only once, and you can attend all editions absolutely free. You don't need to register multiple times. Again, something first in this digital world, a conference which has like 5 editions back to back. This year, our content is also multilingual. Not only are you going to see sessions in English, but you will see sessions in Hindi, Italian, German, Portuguese, Hebrew, couple of those languages. Another first, this is our great step towards diversity and, of course, making this conference more inclusive. We have an exclusive track on SQL Server 2022. This is a great news again, and I'm sure all of you are hearing about SQL Server 2022 after this year's Microsoft build. So watch out for SQL Server 2022 content at DPS. At DPS, content has always been the king for us, and we bring you curated content. In fact, next week you're going to see some huge announcements about breakout sessions, and you would see that we are covering the length and breadth of Azure data stack. So you talk about SQL Server or Azure SQL, managed instance, hyperscale, SQL on VM, or you talk about Azure SQL data warehouse, you are talking about Synapse, Azure Data Factory, Power BI, anything, we are going to cover it in depth. If you are someone who is also working for a data company and you would like to sponsor us and support our community work, most welcome. We are inviting knowledge partners. Just visit Data Platform Virtual Summit, go on to the sponsor section, or just drop us an email, and would love to collaborate with you. So friends, final words: go to dataplatformvirtualsummit.com, evaluate DPS, register for the conference for free, and explore the pre-cons and pick the pre-con that you want. Bookings are open. Special thanks to Microsoft. They have been supporting us for so many years and they continue to have faith in our work. So we are truly grateful to Microsoft. And these are our communities. So we have SQL Server Geeks, Data Platform Geeks, and our flagship event, Data Platform Summit. These are the names you should remember. These are some of our social links. They are there in the chat window. Feel free to join if you're on Twitter, Facebook, LinkedIn, Telegram. We're almost everywhere and would love to connect with you. Some quick housekeeping, and you already know all of this in digital world today, but again, keep your microphones muted, use headphones for best experience, use the Q&A panel to ask questions. If you have audio Wi-Fi issues, just try another network or a Wi-Fi hotspot or something to connect. Please give us feedback. That is very critical. After the webinar is over, I'm going to come back again with some links. And here are the Twitter handles. If you're tweeting and if you're liking what we're doing, please give us a thumbs up. That's The Data Geeks, SQL Server Geeks, and I'm there at @A_Bansal. You can follow us on these channels. Last but not the least, make sure you visit dataplatformvirtualsummit.com. Without any further delay, over to Dejan Sarka for his webinar, Predictive Analytics with T-SQL. Dejan, thank you so much for joining us once again, and thank you for the opportunity to collaborate with you.
Well, Amit, thank you very much for this extremely nice introduction. I'm also extremely happy to be a part of this great event. And I think I will start sharing my screen, which says that your screen will not be shared anymore.
Okay, let's see how can we fix that.
Okay.
Yeah, there you go.
Can you see my
Of course.
screen with the first slide? Okay,
We,
great. Great. So I think it's time to start. I will just, I think, stop video just in case if probably not everybody has a fast connection. So maybe it will be better for some people without video, and I will turn it on again by the end of presentation. So hello everybody and welcome to this brief seminar or presentation about predictive analytics with T-SQL. I am Dejan Sarka, as Amit already introduced me. I'm already here in this community for many years. I deal with SQL Server for more than 30 years, from version 4.2 from 1992. But even earlier, I started to work with statistics and what was later called data mining, machine learning, and so on. I co-authored 19 books so far, and I'm focusing on relational data and data science. So this short presentation is an excerpt from the seminar, which was very nicely described by Amit. And this is based on my latest book, Advanced Analytics with T-SQL. In this presentation, I will introduce how you can implement 3 algorithms with T-SQL: k-nearest neighbor, lookalike model, and Bayesian inference. Now, before even I start with concrete models, let me first explain why T-SQL. Of course, you know that we can do things in R, we can do things in Python, we can use Azure machine learning. And yes, I do also, especially a lot, I'm working a lot in R for decades already as well, from even not so long as with SQL, of course, but also for 20 years for now. Why would I even start working with T-SQL when we have so many algorithms implemented in other specialized languages? Well, there are some big advantages of using Transact SQL. Many people, many database developers, many DBAs have to create some reports, and sometimes they need to include some of these data science algorithms in the report. And like for one report or for something that happens once per year, there is a big overhead if you need to learn a completely new language. Imagine you need to make one-time analysis, and you have to learn R or you have to learn Python. Of course, you will also forget this language once the project is over if you don't use it constantly. So this is one reason. Second reason is the amount of data. All of these analytical languages are based on statistics, and many algorithms are implemented in such a way that they work on matrices. There is a lot of matrix calculation there. So for example, in R and Python, we are using data frame object to analyze. Data frame is something between matrix and relational table. So it looks like a table, but we still have positional access. Order is guaranteed. And these algorithms are also developed in such a way that they are tailored to work on samples. And what if you really need to feed them with huge amounts of data? Well, then definitely you need something faster. These data frames could be fast enough if everything fits in memory. And what if we need to do some spilling on disk? Then suddenly things become much slower. Of course, on the other side, we have relational database management systems, which are developed for decades for work with data. However, they can really work with huge amounts of data very quickly. However, there is a price for this. Usually, we can do only limited data transformations, data analysis with SQL languages. We do this what are called set operations. We work on full sets of data, and we have very limited support for looping. For example, in Transact SQL, we only have while loop, or we could use cursors. And even this looping is usually very slow. So as long as you can do everything with set operations, then SQL languages and RDBMSs must be much faster than R or Python. But you have to avoid loops, you have to avoid cursors, then it's better to go to R and Python. Now, the problem here is that the algorithms that come, majority of them come from statistics. As I said, they are working on matrices, and many times they are working in thousands, if not 10,000s of loops before they produce the result. So what we have to do, we have to select those algorithms that can be efficiently translated to set-oriented operations. And those are those algorithms that could be successfully or can be successfully implemented even in SQL Server with Transact SQL. Now, after this introduction, let me start with the first algorithm, K nearest neighbors algorithm. This is also called instance-based learning. Basically, it means there is actually no training of the model. Training of the model means implementing algorithm on the data set and then storing the results somewhere in another data set and using these results for predictions. So here we have what is called lazy training or lazy learning. I even don't like this expression. It's extremely lazy learning, the laziest possible. There is no learning at all. So what do we use here is just search for cases that are similar to our target case or new case for which we want to find or predict the value of the target variable. We use other input variables to define similarity. Typically, we work with continuous variables, continuous numerics like age, income, and so on. And we simply select k closest cases to the new case and then calculate the average of the target variable in this group. We could also use median for calculation or any other statistical measure. And then this average or median, we say this is our predicted value. Now it's your decision. This is hyperparameter of the algorithm. What is the number k, the number of neighbors you take into the analysis? Small k might lead to high variance. You find some cases that are accidentally together, and then you get predictions with very high variance. These are called local maximums, while large k decreases the variance but raises the bias. Maybe the whole predictions are wrong. Now, what is the largest k? You could use all cases for prediction. Then prediction will be just average of the target variable in the whole data set. One important thing, we need to measure distance between this new case, this case we use for predictions, and existing cases. And we measure this distance with values of input variables. In order to get valid measurements, all variables must use the same scale. I mentioned age and income. Age is measured in years, has values like 20, 30, and so on, while income might be measured, let's say, in $10,000s, and values could be 30,000, 40,000, and more. So if you wouldn't scale these variables, then income would definitely overwhelm the age and would look like this is the only important variable in analysis. So typically you use z-score normalization. So for every single variable, for every value, you subtract mean of this variable or average from this value and divide by the standard deviation. After this, these new variables have all of them mean at 0 and standard deviation at 1. And then here is hyperspace consisting of two input variables. If you have more, of course, this becomes really space, not just a plane. And then you have a new case and you select a couple of nearest neighbors. For example, in this case, I said 3, or maybe I can select 8 nearest neighbors and calculate the average of target variable for those cases and say this is my prediction for my target case. Now, one more thing, what you have to define is a measure of distance. Typically, we use Euclidean distance. You can also use Chebyshev, Manhattan. There are also some other measures of distances. I will simply use Euclidean distance. Before I go even to demos, let me explain one more thing. We have to measure, if we look at this previous slide, we have to measure the distance of this new case from every existing case. So if we have one new case that we want to make predictions and 10,000 existing cases, we have to calculate 10,000 distances. But what if we have 1,000 new cases? Then we have to repeat this 1,000 times. So it's not 10,000, it is 10 million distances that I have to calculate. Of course, this looks like quadratic algorithm. Basically, yes, you can start with a cross join between new case set and existing case set. And we said loops are not acceptable, so also cross joins shouldn't be acceptable. And there is not much you can do here, and I wouldn't even consider this algorithm as one of possibilities to be implemented in Transact SQL if I wouldn't notice this. What I opened here is spatial indexes overview. You know that from SQL, I think 2008 or something like this, we have spatial data types, geometry, geography, and they have specific spatial indices. And here it says in what kind of things these spatial indexes can be useful. And the last thing in this article says the nearest neighbor type of a query also supports spatial indexes. However, only if a specific query syntax is written. And this is the specific query syntax that works also with spatial indexes. So I decided if this is so, let's give a try also to KNN algorithm to see how it works with spatial indices. Actually, this is exactly, you will see the query I need for KNN algorithm. Now let me start by showing you the data. So I will use AdventureWorks DW demo database with DBO with target mail view. Here I have some demographic data of customers, and at the end there is a single flag whether this customer purchased a bike in the past or not. Bike buyer, yes, no. And I want to make predictions for this bike buyer based on some input variables. And you see that some input variables like region are discrete or commute distance. Some input variables we have yearly income, for example, are continuous, and some input variables can be treated either as discrete, either as continuous. For example, number of cars owned. It takes only values between 0 and 4, 5 distinct values. So you can consider this as a discrete variable, but you can also consider it as continuous one if you wish. Of course, theoretically, there is no upper limit, so it is somehow continuous. So it could be useful for algorithms that use continuous and algorithms that use discrete variables. And one more thing, what is the distribution in the whole data set of bike buyer? We have approximately 49 or 48, 49% of buyers and 52, 51, 52 of non-buyers. 0 is a little bit more represented than 1. So let's first start with creating scaled versions of age and income. I will use just these two variables for KNN. So I will subtract from age, average age, and divide it by standard deviation. And the same thing for income. I multiply this by 1.0 to make, especially age is not a decimal, it's integer. So I want to have decimal result. And I'm calculating this overall averages and standard deviations in a simple derived table that returns only a single row. Yes, I'm using a cross join, but cross join with a single row means I'm actually just adding these columns to my source data. So here are my source variables, age, income, and this is how they look after scaling. Let's use this query in a common table expression, and let's then calculate minimum, maximum, average, and standard deviation of both scaled variables. So first we have age goes from minus 1.5 to 4.6. The average is 8 multiplied by 10 on minus 8, so it's something extremely close to 0. Standard deviation is 1. And also yearly income has approximately same minimum, maximum. Also mean is around 0, very, very close to 0, and standard deviation is 1. So scaling apparently works here. Now I want to store these scaled values as coordinates in a geometry data type. Remember, I need to use spatial indexes. So I am just calculating them, and then I'm using geometry point method to create geometry data type. In this query, I'm using also toString immediately to show you how it works. toString gives me the default string representation. So I am creating a point in a plane. Now I will store this in a table. And what I will do is store simply this in a table. And this time I will, of course, not use toString, but I will just store the geometry value. So let's do this for my altogether 18,484 rows. And this is now my table, right? And now I am nearly prepared to start predicting. But before I start predicting with KNN, I want to switch back to slides for a minute because I want to introduce also what is called lookalike model. I will do data preparation only once. So I will finish data preparation for lookalike model, and then I will do predictions with KNN and lookalike model, and then I will use also the same data sets for Bayesian inference. So we will be also able to evaluate which model gives us the best predictions. This is what I simply copied from documentation. If it wasn't there, this possibility to optimize quadratic algorithm of measuring distances with spatial data types, then I wouldn't even bother to go there. Now let's go to what I call lookalike model. So first I will start with a very typical data mining algorithm called decision trees. And you will see that it's a very powerful algorithm, but apparently something that we cannot really implement in transact SQL. So again, I will start with a negative point, like with KLM. So no, we cannot go with cross join, but then maybe there is a solution. What about decision trees? First of all, this is an algorithm that can produce while training, I don't know, 2,000, 10,000 loops, depends on your hyperparameters. So how it goes? This simply assign each case of selected target variable and explain this classification with input variables. So how did we come to bike buyer equal 1? What are the input variables? The algorithm that is used mathematically said is recursive partitioning. Yes, recursion is again something you do not want to hear in transact SQL, right? So initially we have all cases in one big box. And we have target variable like bike buyer in our case, which has distribution, let's say approximately 50-50. Now the algorithm tries all possible breaks using every single input variable, breaks into subgroups, and then calculates the distribution of the target variable in subgroups. So we can check what is the purity of the target variable in subgroups. For example, when I have only two possible values, like with bike buyer, simply probability or frequency distribution is a good measure. Initially, we had 50-50, then let's say we split over, let's say, some two values of householder flock, and we get distribution 60-40, but then we try to split with let's say another very binary variable like, I don't know, education, low, high, and we get split 30-70, and apparently this 30-70 in one class, and let's say 80-20 in second class, and apparently this split is better. So we keep this split. And then we repeat the splitting process. So we create smaller and smaller classes. Again, checking all possible breaks. You can imagine that this can go forever. Actually, this is even the problem of decision trees algorithm. If you don't stop it somewhere, it will come to the point where you will have one case or single case in each subclass. And in this single case, the distribution of bike buyer will be ideal, either 1 or 0. But of course, this is useless for any kind of predictions. This is called overfitting. So we have to stop it somewhere. Typically, we simply say, don't make further splits if there would be, let's say, less than 20 cases in some target class. Here is an example. Let's say we have some questionnaire. How did you like our product? And we have two input variables, age and education. And initially, 55% of people like the product, 45% no. First split was done over age, older than 35. We have raised those that liked 73%, and younger than 35, 33% didn't like the product. Then we continue the split over education. So with older people, we make split education 2 and more and 2 and less. And then we have even purer class of those who liked our product, higher education, older people liked it more. And then we continue with split of the second class of younger people. And again, we get even some purer subclasses. Now, as I said, imagine that this would be implemented in SQL, loops and recursions. No way. Similarly, like quadratic algorithm cross join is a no way. So what is then lookalike modeling? This is the idea to combine KNN with decision trees. So instead of KNN works with continuous variables, we are working with discrete variables. And imagine that we have this group somehow created. Now we just have target new case. We just have to find the appropriate group and calculate the value of the target variable there. If it's continuous, we can again calculate something like average. If it's discrete, we can calculate the frequency distribution. So what we need to do is split the data in a single split using multiple input variables. And then we calculate the distribution of target variables in these classes of input variables. And this can be extremely, extremely efficient. Now, this is what we are doing here. We are calculating, for example, distribution of bike buyer in different regions. And we see that there are more buyers in Pacific than in North America. And with number of cars owned, with 0 cars and 1 car, we have more buyers. With 2 and more cars, we have more non-buyers, and commute distance, and so on. So this is what we are doing. And we'll do this in a single pass through the data. So let's go and prepare the data also for look-alike modeling. I will calculate groups in advance. Now here is the problem. This algorithm look-alike modeling cannot be so accurate as decision trees because I will define these groups in advance, and also the order of variables, or all variables in these groups will have equal importance. So I will just create a new artificial variable. I will call it grouping factor, GF. So I will combine commute distance, region, income, and number of cars owned. As input, I am using table that I created in the previous demo. So I already have there also this geometry data type. And I can do any kind of recording I want. For example, here I will recode commute distance into 3 distinct values, 1, 2, 3. And then, for example, region, I will also use 3 distinct and 0 if it's missing. Also, income, I will use split it with entire window aggregate function or window this statistical function into 3 groups. And number of cars owned, I will treat it now as a discrete variable and create it even with less classes. Why 4 variables? Why not more? Why not more classes? Because of this. I will also calculate count of number of cases in these subclasses. So let's do this grouping factor and then count how many cases are in each group. And you can immediately see that not all groups are useful. So like first 14 groups are not really useful, or maybe let's say at least 10 cases, then first 9 groups are not really useful. If I would use more variables, then of course I would get more accurate results, but many of them would be really unreliable because they would be based on groups with very, very low count. more input variables, more distinct values of these input variables means simply more groups with less cases in each group. Of course, at the end, I have some groups that are really huge. This could be further split. This is what decision trees does. The decision trees algorithm does. It would stop with the groups at the beginning, but continue splitting the huge groups. So again, we cannot expect so good results as with decision trees. Now I'm prepared to create what are called training and test sets. I will simply split my 18,000 cases. 70% will be for training the models, 30% for test set. So this will be mimicking new cases, and I will predict bike buyer target variable for these new cases. But since these are also known cases, we already know the result. I will be able to measure the accuracy of my predictions. So let's go, and I will start with 30% for test set. Why 70-30? This is an old habit. There is no big mathematics here. Usually people use 70-30, some maybe prefer 60-40. I always use 70-30 without any big mathematics. So I am creating test table, and I'm doing order by crypt_gen random function. Please note that how to select randomly rows and with Transact_SQL. If you search, if you Google for this, you will find many blogs and articles that you can use new ID for this. Crypt_gen random is much better. New ID is giving you equal distribution, so every value has equal probability, while this one is really doing Gaussian distribution, so it's kind of better. Not big difference, but a little bit more randomized. So I prefer this one. And this is my test set and training set. And I'm done with data preparation for now. Remember, there is no real training. So training means use training set, implement algorithm on it, and store this in some model. This is another table. I will use this training for Bayesian inference. Now, let's just add customer key, primary key here. IMIT index is only on training test, so I will use it for fast lookup. And non-clustered index, grouping factor, and bike buyer, it will be even covering. Now let's do KNN. And I will start without spatial indices, and I will just test how the spatial indexes are good. So I will set statistics time on, and I will calculate. So I will use TM test, and without a reply, I will select top 10 cases from TM tray where this distance is not null. So I have ST distance between new case and existing case, and order by, so top 10 ordered by distance ascending. So let's, and then I will calculate over all of these 10 cases. I will calculate average of bike buyer, and say if average is greater than 0.5, then this will be value 1 predicted, otherwise value 0. So let's execute this query, and yes, this query is actually doing more or less full cross join, because for every case I must find distances to all cases. So this is still somehow possible with my computer. It should finish in less than a minute. It already started to return results, but definitely I wouldn't do it if I would have like 100,000 input cases and 50,000 test cases or million of input cases. So far, right, doesn't look extremely promising, but yes, what I'm doing is full cross join. If it will not stop in about a minute, I will stop it and maybe show less rows, but let's see. Usually also first time is slower. If I would execute it again, would be a little bit faster. because everything is already cached. So let's see. So elapsed time 45 seconds, and CPU time I used 4 threads. It's even very high, 162 seconds. So let's create the spatial index. And yes, you can play bounding box means what are the limits of input variables. The lowest values were were not lower than -2. The highest were not higher than 5. And then you define how many cells you have in each grid and so on. So you can play also with these indices. But let's now execute the same query again. And this time I am using spatial index. And let's see how much this spatial index can improve the performance. Please note that with a more precise index, the building of index would be slower, but I could afford this because building was extremely fast, but query would then be faster. Still, I couldn't really get lightning performance. You see, we have, maybe I will try to execute it another time because spatial index should be loaded in memory, but you see it was 31 seconds. Also, CPU time was lower. Yes, it's somehow better, but not really something that you would use with huge amounts of data. So it doesn't look like extremely promising unless, of course, if you are predicting only 5 new cases, it's not a problem to make a cross join of 5 cases with 1 million cases, right? This is not a problem. But for really huge tests and training sets, this wouldn't work. So let me calculate the accuracy. So I will, oh, I didn't even look, check the results. I didn't even check the results. Let me execute this query again, but only until it starts returning results. So what I'm returning is original bike buyer, in this case, original from the test set, and what is predicted. Okay, so I will just stop it here. So we have original, this is probability, and this is the predicted value. And now let's calculate the accuracy. What I will do is so-called classification or confusion matrix. So in this case, I will calculate what are values that are predicted true and actual true. These are true positives, and predicted false and actual false. These are true negatives. Predicted true, actual false are false positives. Predicted false, actual true are false negatives. Okay, so apparently it will again normally be around half a minute. And yeah, even more now. Okay, here we are, and let's see what we got. I got these test results. So these are true positives, and let's calculate the accuracy. And here we have true negatives. And here we have false positives. And here we have false negatives. Of course, if we look at here, how is this formula? These are true predictions divided by the total number of cases. And this is the accuracy. In this case, you see this, I get random data sets, so it is slightly different than when I test it. So 61%, this is slightly better. I used only two input variables, but I already got better predictions. Remember, initially I would have 50% accuracy. So even with two input variables, I got some improvement. Now, lookalike model is extremely efficient. Now I only need to check the appropriate group for each case. So I'm using outer apply, and checking for the appropriate grouping factor, and I have covering index. All I need is bike buyer and grouping factor, so I can calculate average of bike buyer and then define this as bike buyer predicted. And if you compare this to KNN, this was executed instantly, and I have the actual bike buyer and probability and predicted. So this can be used, of course, also now on really huge data sets. Even if you have all continuous variables, you can still prefer lookalike model to KNN, because remember, I use entile function to discretize the continuous variable income. And let's see. But remember, here I used actually 4 input variables. Grouping factor was combined of 4 input variables. So let's see the accuracy in this case. And already from these numbers, you can maybe notice that it is slightly better. Okay, and the last number. And let's calculate the accuracy. And 64%. This is already pretty decent accuracy. This is already pretty decent. You might say, okay, you would expect better. But let me first tell you that I did a lot of tests with R, with real decision trees on the same data set, and I could hardly get up to 70% accuracy. And with I don't know how many input variables, with only 4 input variables, with practically instant result, this is extremely useful. And this is algorithm that I can really recommend. With more data, you can get even better accuracy. You could also test with different input variables. You could test with different groupings, a little bit of manual work, but the actual model is extremely fast. There is no train. Now, the last thing, in this, let's try another algorithm called Bayesian inference. Remember, we didn't have any training. Here, we will have training with a single pass-through data. So a little bit of formal definition, how it works, calculate probabilities of each possible state of the input attribute given state of predictable attribute. What does it mean? Let me go a couple of slides further here, and then I will go back. So here we start with the opposite process. So we calculate distribution of input variables in classes of target variable. So before we calculated distribution of bike buyer in classes of region, now we are calculating distribution of region in classes of bike buyer. So the opposite process. So how does it work? Now imagine that I am buying, let's start with 2 possibilities. Imagine that I'm buying a second-hand car. From magazines, I realize that 30% of them are faulty. Now I have a good friend that is a mechanic, and this friend accepted to go on a quick drive with me. And after this quick drive, my friend declares car as good or faulty. Of course, my friend is also not correct in 100% of time. If car is faulty, it will be declared in 90% time correctly as faulty and in 10% incorrectly as good. If car is good, it will be incorrectly declared as faulty in 20%. Altogether, my friend will judge 41% of cars as faulty and 59 as good. Now, please note, if these cars are judged as good, right, then only in this upper point, 0.03, this is where my friend actually made a mistake. So we can create a reverse tree. Out of this 59% declared as good, 95% of them were actually good and only 5% were actually bad. So these are posterior probabilities after classification. If I buy a car that was declared by my friend as a good one, I will get 95% probability that is really good, which is much better than my initial option, which was 70% only. Now, this is the opposite process. So how do you calculate these posterior probabilities? For example, here I have bike buyer, and then I have just a subset of data. So for region Pacific, I have in this class 0, 0.14 cases. And in class 1 of bike buyer, there is 23% of people from Pacific region. So apparently, let's say 77% of this region in class of bike buyer 1 are from Europe or North America. And then also we take only one possibility for number of cars owned. If number of cars owned equals 1, then we have in this bike buyer equals 0, number of cars owned 1 has probability 0.23, or 23% of people that do not buy bikes have 1 car. Okay, so this is distribution of input variable target in classes of target variable. So how do we calculate then the posterior probabilities? So probability for 0 value are this from previous slide, A multiplied by B divided by A multiplied by B plus C multiplied by D. This simply means A multiplied by B. So here on the right, I have A and B. These are the actual 0 bike buyers. And then we have divided by A multiplied by D plus C multiplied, A multiplied by B plus C multiplied by D. And similarly for probability for the positive outcome. So we have then this option C multiplied by D divided by C multiplied by D plus C multiplied plus A multiplied by B. So what you see, I have these probabilities in each row. I can calculate some with some aggregate function. It would be easy to calculate this if in formulas I would have, instead of multiplication, I would have plus. Then I could use some aggregate function. Unfortunately, I don't have this. I must create aggregate product. And how do I change product to sum? Well, it's very simple. I use a little bit of mathematics. Remember, logarithm of A multiplied by B equals logarithm A plus logarithm B. So if you summarize logarithms, you get a logarithm of the product, and then you use the reverse option exponential function. And this is how you can get the actual probabilities. So remember, we have training and test set already created. This is all together what we have inside, couple of variables. And I will calculate single feature distribution or single input variable in class of target variable. So class of target variable will be 1, and I will calculate distribution of region, right? This is in class 1. And then I can, of course, calculate with union also for second class. And I will use couple of input variables. So what I will do, full calculation of 3 input variables, region, number, count, commute distance. I will simply use grouping sets. And I have bike buyer equals 0. This is distribution of commute distance. These are percentages. Number of cars owned from 0 to 4 for bike buyer 0. Region for bike buyer 0. And then we have commute distance for bike buyer 1. And then we have number of cars owned for bike buyer 1. And then we have region for bike buyer 1. Now I will simply create, and remember, this is my test set. I still have 5,000 and so many rows in test set. Now I will do the actual training. Remember that with lookalike and KNN models, there was no training. Actual training will implement the algorithm and store it into resulting table. So I will just do this with a single pass through data, calculate all of these numbers. And my model is actually a new table with all these combinations. Now I am just showing for region Pacific, number cars owned 1, commute distance 2 to 5 miles. So altogether, I have 26 rows here in this table. And now remember aggregate product, I can use exponential function on sum of logarithms of values. So let me do this for a single case. So I will say for bike buyer 0, I will use region Pacific, number cars sold, commute distance 2 to 5 miles, and also calculate positive percentage, right, for bike buyer 1, and then calculate positive and negative probability. So for this combination, is, you see, these are likelihoods and these are the actual probabilities. So for combination region Pacific, 1 car, commute distance 2 to 5 miles, I have nearly 73% of probability that this person is a bike buyer. So let's do a prediction query, right, using constants. So this is prediction query. This is like nearly 73%. Now I will, instead of doing this row by row, I will simply create prediction function that will calculate negative and positive likelihoods and then calculate the probabilities. So this is tabular function, which I can now efficiently use with cross apply, and I get full prediction. So I have original value. This is likelihood for positive outcome and the actual prediction. If likelihood or probability for positive outcome is less than 0.5, then predicted is 0. Again, you can see some values are correctly predicted and some values are wrong. So final thing, let's calculate the accuracy. And again, you can see that this is extremely fast. Training was single pass through data. So predictions are now even faster than with KNN. I know with lookalike modeling, but with lookalike there was no training. And let's calculate the accuracy. Last thing. Now, also worth mentioning, accuracy is a very basic measure, depends on your business problem. You might select other measures, maybe true positives are more important, maybe false negatives are more important, and so on. So accuracy nearly 62%. With 3 input variables in lookalike modeling, I used 4 input variables. I got the best accuracy. So all together, here is I see also on the other screen, will the scripts be shared? Yes, the scripts will be shared, definitely. Any of these organizers, you can mark the question also as answered. I will just ask the organizers, how do we? No, I actually already shared them. I already got email. I did it this morning. Sorry about that. You will come to my age and then you will also forget. I can easily remember what I did in high school, but what I did this morning, this is harder to remember. Anyway, altogether, lookalike modeling is extremely useful. Bayesian inference also. KNN, I mean, yes, it can be used if you have only few test cases. Even with spatial indexes, you get slightly better performance than full cross join, but I frankly expected more. So thanks again to our hosts. Do we have any open questions? I don't
All
see.
right,
Oh,
Dejan. Looks like no questions at this time. But Dejan, why don't you talk about your pre-con, the DPS 2022 pre-con that you're doing, and what are you really covering in that pre-con?
okay, thank you. So I will go through really broader process of data analysis, and so I will start with data overview with descriptive statistics. I will go to simple predictions with linear regression, and then I will switch to more advanced methods for data preparation, including proper recording. And then I will also show you things from information theory, how you calculate entropy, which is like variance on steroids, very, very useful. And then I will talk, let's say, about moving averages, but also not just simple ones that you can calculate with window aggregate functions, but exponential moving averages, which are very useful in financial modeling and also useful for forecasting. So we will do also forecasting with regression, auto regression, and with exponential moving averages. We'll talk about analysis over time, survival analysis, hazard analysis, and also advanced analytics. I will also cover lookalike model and Bayesian inference, but also association rules and even some basic text mining with Transact-SQL, only with very, very efficient algorithms. And we will have, just to give you the idea, there will be more mathematics than it was in this short presentation. But you see that many things are based on mathematics. Without mathematics, it's kind of hard to make things very, very efficient. So there will be even more mathematics. So I will also explain mathematics behind and then show implementation in Transact-SQL. I would say in short that you probably didn't see so advanced Transact-SQL yet. At least I didn't, and I'm working with it for 30 years.
Thank you so much, Dejan. So, friends, first things first, thank you so much, Dejan. Friends, this is your opportunity to give us some feedback, put down your comments. The link is there in the chat window. The speaker, we as organizers, we always look forward to hear from you, and take a few minutes to click on that link and give us some feedback. We would love to hear your comments, and we really want to hear from you. What did you like about this content, this webinar? What did you hate? What did not like? And we want to hear everything around. So please do not skip that. That's the first thing. Second, yes, if you're really keen on deep dive demo focused content, as Dejan talked about, this webinar was kind of a precursor. Some quick demos here. Thank you, Dejan. And of course, the 8-hour virtual class will have a lot of deep dive content and more demos. So make sure you sign up for this pre-con. It's very well curated content. I know Dejan is one of the world's best when it comes to Transact SQL. So make sure you get it and use this discount code 60 steal it. The link is dataplatformvirtualsummit.com. Go to the pre-con section, explore his pre-con and everybody else's pre-con as well. With this, thank you very much, all of you, for joining us. We really look forward to welcome you at Data Platform Virtual Summit 2022. Goodbye and have a nice day. Stay safe. See you soon in the next webinar next Thursday, same time. Stay safe.